All right, you are going to need a graphing calculator for the next few lessons. Today we're going to do graphing sine and cosine. So we're going to first start with the unit circle and go ahead and fill out the table for each of the functions. So we're just doing sine of x. So sine of 0, we're just going to fill in these and plot the points. Sine of 0 is 0. Sine of pi over 6 is 1/2. And these are all, if you're having trouble figuring out that sine of pi over 6 is 1/2, then you draw it on your x and y axis first. Where's sine of pi over 2? It's up here. So you just hopefully will have these memorized at some point. Sine of 5 pi over 6 is 1/2. Again, that's positive. It's above the x-axis, so it's going to be positive. Now we're at pi. We're at the x-axis. So that is 0. 7 pi over 6 is below the x-axis, so that's negative. Negative 1/2. And then we have negative 1, negative 1/2. These are all values that are coming from the unit circle, and 0 again. So let's go ahead and plot those. All right, so we plot them just like we plot any points on a graph. And here is our nice curve. Oh, let me try that again. For the sine of x. Now let's go ahead and graph cosine. So we plug in our values from the unit circle. So cosine of 0 is 1. Cosine of pi over 3 is 1/2. Cosine of pi over 2 is 0. Cosine of 2 pi over 3, which now we're getting to the second quadrant, is negative 1/2, because now we're dealing with cosine, and cosine is x values, and x values on the left side of the y-axis are now negative. Sine of pi is negative 1. Sine of 4 pi over 3 is negative 1/2, 0, 1/2, and 1. So now we go ahead and plot 0, 1. Pi over 3, 1/2. Pi over 2, 0. 2 pi over 3, negative 1/2. Pi, negative 1. 4 pi over 3, negative 1/2. 3 pi over 2, 0. 5 pi over 3, 1/2. 2 pi, 1. So what's happened is we've got one full period. Oh, you probably could draw that better than me. There we go. So we're starting at 1, we go all the way down to negative 1, and we come back up to 1. One full period of of cosine. All right, so go ahead and go to your graphing calculator and take a look at these basic graphs. So if you graph sine of x and use these for when you click window, and you use those as your boundaries. But what happens when you take a 3 and you throw it in front? So I've got on my graph here, I plotted the sine of x and then 3 sine of x. So 3 sine of x is red. So let me go ahead and graph it. And you'll see that it is 3 times as tall. We call that the amplitude of the graph. So if I go back to my so that's just for the first one. So go through and look at all what happens if you add a 3 at the end. I mean, just like if you have a regular function like a quadratic, y equals x squared, and you add 3, what happens to the graph? It takes the whole graph and it moves it up 3. That's what happens to your sine of x function. Now this is a phase shift, so this changes. I want you to take a look at this on your calculator, and then I'll show you the answers in just a second. And then what happens when you throw a negative in front? What happens? And I think there's one more. Yes, this is a period change. So take a look at those, and then I'll press pause, and then we'll come back. All right, so we just talked about the vertical stretch. Okay, it just stretches the graph and makes it taller, right? The vertical shift takes the whole graph and moves it up or down. The horizontal shift is inside the function. So just like from algebra 2, when you had a horizontal shift, when you had a change that's inside the function, it takes the graph and it moves it left or right. It's actually the graph paper that's moving the opposite direction, but it goes the opposite direction of the sine. Okay, now when you have a negative in front, that's a reflection, but it's over the x-axis. Just like if you had y equals x squared and you throw a negative in front, what happens? Well, here's your x squared, and here's your negative x squared. It takes it and it reflects it over the x-axis. Same for the sine graph. And a period change, this is totally new. If we have one full period of sine, which we graphed earlier, we started at 0, went up to 1, down to -1. Let me just show you. And back to 0. Here, that's one full period of sine. This is one full period of cosine. If you throw a 3 in there, you're going to have 3 full periods in this period. So, where are my answers? Here we go. So what happens is it goes up and down 1, 2, 3 times in the time it normally takes one period. So those are changes in period. So what we're going to do now is we're going to look at the graph, and we're going to look at what the amplitude is, what the period is, how we're going to graph or count on the x-axis, if there's a phase shift, a vertical shift, if there's a reflection, and we are going to try and graph these functions. Now at first this can be a little complicated, but with practice it gets much easier. So we're going to go ahead and start with the first one, and it's pretty basic. So the first one, all we see is it's pretty close to the sine of x, and we've already graphed this on the graphing calculator, so we have an idea of what it's going to look like. So if we were graphing in blue, if we were graphing the sine of x, okay, well, let me back up. Let's go ahead and start with the amplitude. The amplitude is the absolute value of the number in front, okay, so that the absolute value of 3. Sometimes you have a negative, it's asking anytime you have absolute value, how far away is that number from 0? 3 is 3 away from 0, so the amplitude is just 3. The amplitude is always positive. The period, if you look back up here, the period for graphing sine and cosine is always 2 pi over b, and b is the number in front of x. In this case, there's no number, there's a 1 in front of x, okay, so that's just 2 pi over b, so the period is the same normal 2 pi. And if you looked at our original graphs from the very first, right, we started here at 0, we went up, down, and came back to 2 pi. That is one full period. All right, so where are we at? Okay, the unit. We want the graphs to look very similar. We want a very nice, easy way to graph it. And the way we do that is we just make the period graphable in a nice, easy way. And we're just going to take that period and we're going to chunk it into 4 even pieces. Okay, so in this case, if we have 2 pi, we're just going to divide it by 4. And 2 pi over 4 is pi over 2. So that is what we are going to number the graph by. So I'm just going to put a pi over 2 there, but we know that this is pi over 2, this is 2 pi over 2, so that's pi, 3 pi over 2, 4 pi over 2, which is 2 pi. Okay, so normally we'd get to 2 pi twice as far down here, but we're counting. Actually, I don't want to confuse you, so erase that thought. Okay, so where am I? All right, I'm at the unit. We just numbered our x-axis. All right, in this case, we're starting off fresh, so we do not have a phase shift or a vertical shift. So the domain, it's just going to, well, let's not worry about that yet. Let's go ahead and graph. So 0, in a different color here. So we are ready to look at this. So the sine wave, and we're graphing sine in this first example, goes from 0, high, 0, low, and back to 0. Okay, we've chunked it into 4 even pieces. So now we can start our sine graph at 0, go up to the high value. In this case, the high value is going to be 3 because the amplitude is 3. So 0, high, 0, and then the low value is -3, and then back to 0. Now we want to do that a couple times, so what I usually recommend is that you do that all the way up and down the graph, in both directions, okay? And then you just kind of draw in your graph. Okay, the domain is -infinity to +infinity. It's the same for all sines and cosines. And the range goes from the lowest y value to the highest y value. That's going to be -3, including -3, so hard bracket, 2, 3, hard bracket. All right, let's try the next one. The next example is cosine. So cosine starts here. It starts high and it goes to 0 and then low and then back to 0 and up to high again. So let's go ahead and start. Our amplitude is the absolute value of -2, which is 2. The period is 2 pi, because it's 2 pi divided by the 1 that's in front of the x. The unit will be the same as the previous one, so that will be pi over 2. So we go ahead and just write pi over 2 on the graph there. We have no phase shift, no vertical shift. Our domain should be the same as usual. And now let's go ahead and graph. So this is cosine. So normally we would start at our high value. Now our high value in this case is -2. So instead of starting at 2, we would start at -2. -2. So it goes from high 0, low 0, but we've got a negative in front, so it's going low 0, high 0. Okay, low 0, high 0. Low 0, high 0. You fill in the rest of your points, you draw your graph. The range is from -2 to 2. Moving on. All right, so now we're going to have a little bit of a change here. We're going to make these, we're going to change the period a little bit. So now the b, the number in front of x, is a 2. So the amplitude in this case is just a 1. Okay, because that's a, that's the number in front of the sine. The period is 2 pi divided by b. So 2 pi divided by 2 is just pi. So the unit, when I take that and divide by 4, I'm going to be counting differently. I'm going to be counting by pi over 4 now. No phase shift, no vertical shift, domain's the same. And let's start. So we are 0 high, 0 low, 0. 0 high, in this case is just 1 because there's a 1 in front of our sign. 0 high, 0 low, 0. And that is good enough for this example because I only have a couple minutes left and I want to make sure I get all of these. So let's go to, we're going to skip the U-try. We're going to go to B. So amplitude 1. Now the period is normally 2 pi, but right now it's going to be 2 pi divided by 1/3. We don't ever divide by fractions. We multiply by the reciprocal. So 2 pi times 3, that's going to be 6 pi. If I take that, cut it up into 4 even sections, each of those sections is going to be 3 pi over 2. Because if I do 6 pi divided by 4, that's 3 pi over 2. So I am counting by 3 pi over 2. No phase shift, no vertical shift. Let's go ahead and count. Okay, the amplitude is 1, and we're not reflecting over the x-axis, so we're just going to go high 0, low 0. So high for cosine is 1, 0, low 0, high 0, low 0, and so on. And then you just draw your graph through it. And try to do more points than I am. I'm just trying to be quick for your video, so I finish in 15 minutes. Here's the answer to the U-try. If you want to do it, press pause, look at it, your choice. Moving on. So example 3. So now we're going to have a phase shift or a vertical shift. This is a little bit more tricky. Okay, so the amplitude is the number in front of 1, the absolute value of the number in front of sine, which is 1. The period is still 2 pi. Take that 2 pi, cut it into 4 even pieces. So each of those pieces is pi over 2. Label your graph, pi, starting at pi over 2. You can label the whole x-axis, but I usually just do the first one. We know the domain is the same. To find the phase shift, we take inside the parentheses and we set it equal to 0. So the phase shift is pi over 2, and that's plus. It's a positive. If it was negative, it'd be negative. All right, so that means, and we also have a vertical shift of 2, so that's going up 2. So you go ahead and you mark your vertical shift with a dotted line. And now we have to find our new starting point. Our original starting point was at 0, 0. Now our starting point is going to be at vertical shift 2, horizontal shift pi over 2. Okay, so that's the phase shift and the vertical shift. So the phase shift is our x and our vertical shift is our y. That's our new starting point. So now we just take out a yellow. Think of this as your x-axis and this as your y-axis, and you're just going to graph. So 0 high, 0 low, 0 high. Done. I'm going to continue doing more examples in the next video if you feel like you need more practice, but the range for this one is 1, 3.